To open the safe, first the user must enter the correct 4-digit passcode and press the hash key. If the password is incorrect, the user must enter the code again. If a mistake is made entering the code, the star can be pressed to reset the input. When the correct passcode is entered, the user is prompted to approximate their access card to the reader. If the card is incorrect, the safe will remain closed. Once the correct card is tapped, the servo motor turns 90 degrees and the safe can now be opened. Once the contents of the safe have been acquired, the star key can be pressed to relock the safe, and then it can be powered off. The PCB for this project, designed in Eagle, hosts the ATmega 328P along with the timing crystal. The ISP header for programming and a reset button support the use of the microcontroller. Two voltage regulator circuits, 5 and 3.3 volts, support the voltage levels required for the different components. Their wires are connected to the board via terminal blocks, offering a reliable, semi-permanent connection. The power button is a latching push button and features an internal LED to provide the user of the safe's on or off status. The display for this project is a 128 by 32 pixel OLED. It operates on the I2C communication protocol, meaning it only requires two microcontroller pins for the serial data and serial clock lines. There are special I2C pins on the ATmega 328P. The SCK pin provides the clock signal to sync the devices, and the SDA pin is where the data is transferred from the slave to the master, or vice versa. Up to 128 devices can be on the bus, as each one has a unique address to identify it. The 4-row, 3-column keypad is configured as a matrix, so it does not require 12 individual microcontroller pins. Instead, there is one pin for each row and one for each column, meaning 7 pins are required in total. When a button is pressed, the row and column pins corresponding to it get connected. Through the use of setting pins high and low, the microcontroller can determine which row and column the button is in, and there is only one button corresponding to that. Thus, it knows what digit has been entered by the user. The RFID reader in this project reads data from any RFID card approximated to it. Only the correct one can open the safe. This reader uses the RC522 chip and acts as a breakout board for it. It requires 3.3 volts for power instead of the standard 5 used in the rest of the project. As the card has no internal power supply, the reader's antenna creates a high-frequency signal which powers the card by inducing a voltage across its coil. The card then uses a process called backscattered coupling to send its unique 4-byte UID to the reader by creating its own high-frequency signal. This signal is picked up by the reader and transmitted to the microcontroller via SPI communication. This protocol requires a serial clock line for the clock signal, a slave select line for the master to choose a slave to communicate with, a master out slave in line for the master to send data to the slave, and a master in slave out line for the slave to send data to the master. Each RFID tag has its own UID, and once it is sent to the ATmega 328P by the reader, it only opens the safe if the UID matches the one defined in the software. The servo motor in this project acts as a door latch. It rotates 90 degrees and unlatches from the bolt when the safe door should be opened. Inside the servo there is a DC motor, potentiometer, and control circuit. The DC motor is connected via many gears to the external arm of the servo and the potentiometer. The motor is sent a frequency from the microcontroller via its data line. This frequency informs the DC motor how much to turn in order to turn the arm of the servo a certain amount of degrees. The potentiometer, acting as a voltage divider, also turns and outputs a voltage level. The internal circuitry associates this voltage level with the amount the motor should be turned. If the motor is not turned correctly as instructed by the frequency, the internal circuitry adjusts the DC motor accordingly. The physical design element of the project is the safe itself, constructed out of 6 pieces of wood cut from a larger sheet. The pieces are held together using right-angle brackets, and the door is attached with 2 hinges, with the handle being a large eyelet. Holes for the components and their wires are drilled in the wood, and everything is painted gray. The code for this project is designed in a modular way. Each correct authentication step made by the user advances it, until the servo is eventually rotated and the door can be opened. It is explained in detail in the project report.